Hi, this is Corvo and Shawn, and we're presenting our Bitcoin price prediction. And our idea is the price of Bitcoin in US dollars is correlated to the total amount of transactions happen within a strict time period. And our general approach to the problem is we first acquire and parse the data from different sources, shape our data into useful format, and then create a prediction model from the training data. And then we verify the data with a smaller set of testing data set. And the way how we acquired the Bitcoin price data is that we downloaded the CSV in minutes from cryptodatadownload.com. And then we converted the date format to seconds using Python script. And meanwhile, we converted the New York time zone to universal time. And in terms of acquiring raw block data, we retrieved raw binary data from the blockchain.com, where we use the API, and then converted the hex encoded data into JSON format using Bitcoin parser library called PYBTC, where it outputs a block data on one line in a text file. And the number of blocks we used is 1,500 blocks. And we're going to talk about how we used the Spark to combine price from the raw data and the prices file. First, we look at the time. So the time field is the time at which the block is mined in seconds and then sealed up to the nearest minute that is provided in the prices data, so that we can match the time from raw block data with prices data. And the second field is the price, which is the closest to the time of when the block was mined. And the third is standard deviation. So we find the distribution of the Bitcoin price in the transaction for each block. The amount of Bitcoin in a block. So that is the sum of all the values of transaction in one block. And the difficulty, which is the time that it takes for a block to be mined.
So we went through each transactions apart and accumulated the total amount of transaction in block, and then we joined the data with the historical Bitcoin price data, also separated by block, and merged them together for training and testing. So we implemented the prediction model with PySpark and Panda, and when we decided to use linear regression on 4 different variables as an independent variable to Bitcoin change in price as a percentage, and then put them together into a feature vector to fit into the linear regression model. So we applied the training model to the testing data, and then we later will compare it to the actual price during that time using this formula, which is current price equals to previous price times 1 plus predicted percent. So we use number of transactions, standard deviation, the difficulty, and the total amount of Bitcoin in the block. So after training the model, we come up with this graph of the actual price versus the predicted price. And also we have the R2 value of R square value of the linear regression model, which is not very good, to be honest. We have a minus 0.05, which means that there is no clear correlation between the predicted, between what we set as independent variable and the actual price. Our test data set has 30 values that is different from training data set. So our conclusion is that there isn't an obvious linear correlation between the set of independent variables that we set and the price of Bitcoin in US dollars. So I think one of the reasons might be that the volume transactions are not indicated direction. We don't know which part is selling, which one of them is buying, and then we can't really determine which way it will go, whether it's down or up. And then also some variables such as the difficulty of mining or the standard deviation of transaction may not affect the price of Bitcoin.